Hey guys, this week we're going to get back into trig and finish up Unit 4. The second half of our unit is on graphing trig functions, and this is super important, so we're going to go nice and slow, and today we're just going to start with graphing the parent sine and cosine functions. So we got the function f of x equals sine of x that we need to graph, and because we don't know what it looks like just yet, we're going to start with a t-table, just like how we start graphing any function that we've never seen before. Start with a t-table, pick a few points, and then see what the graph looks like. Now, because x is what we're taking the sine of, whenever we take the sine, cosine, tangent of a value, it's always sine, cosine, and tangent of an angle, right? So in this case, x represents the measure of an angle, and it's going to be in radians instead of degrees. So x represents the measure of an angle in radians that we're going to take the sine of, and f of x just represents the output. So we're going to graph this without a calculator using what we know about the unit circle. So I have the little unit circle on the right side there to help us. And so let's think about what angles we can take the sine of without a calculator. Those will be our special angles, right, in the special right triangle. So let's start with 0 radian or 0 pi radian. And if I look at my angle of 0 pi radian on the unit circle, remember that sine is y over r. Because the unit circle has a radius of 1, sine is just the y coordinate. So the y coordinate of this point is 1, 0, so the y coordinate is 0. And then the next angle that we can take the sine of without a calculator might be 30 degrees, right? Using our special right triangle, the y coordinate would be 1/2. So 30 degrees will be pi over 6, would give us 1/2. And then the next angle would be pi over 4. And the sine of pi over 4, the vertical distance here, would be radical 2 over 2. Hopefully this is coming back, a good review of our unit circle. And then the next angle will be 60 degrees, which is pi over 3, which is really just my 30, 60, 90 triangle again, except the vertical distance in this case is radical 3 over 2. And then pi over 2 is 90 degrees, right, up here. And the coordinates of this point is 0, 1. Okay. And I'm just going to graph these so you can see what it looks like. I'm going to start with 0, 0. And pi over 6 is really a third of pi over 2, which will give us 1/2, maybe somewhere over here like that. Okay, and you can see actually that on the x-axis and the y-axis, your scale is like a regular x-y axis scale by 1, but they also place these values there for you to show you where pi over 2 is. Pi is 3 pi over 2 and 2 pi is, because if you think about it, pi is just 3.14. So it makes sense that pi units would be right here a little bit past 3. Okay, and then half of pi would be right here. And then 2 pi would be 3.14 plus 3.14, which will be a little bit past 6. So those are there. Remember, pi is just a number, and so is 2 pi. All right, so over here, and then I'm just going to graph. Well, these ones are a little bit hard to figure out, and we might need a calculator to do it, but we're not going to do this every time because we don't want to use these values that is hard to calculate and also kind of hard to eyeball and graph. So we're just going to actually use these ones, your quadrantals, your coordinates on your quadrantals, because those are nice to graph. So pi over 2 would give us 1. So pi over 2, 1, here it is. And you can see that at pi over 6, pi over 4, pi over 3, the y value slowly increases and it gets closer and closer to 1. Now the next quadrantal that I'm going to use is this one, which is pi. And the y coordinate is 0. The sine of pi is 0. And then this point right here, how about 3 pi over 2? So the sine of 3 pi over 2, y coordinate of this point down here is going to be -1. Okay, and then finally 2 pi. the sine of 2 pi is back to 0, which is 0. So these are the 5 critical points that's going to help us make our graph because they're nice and easy to graph. And so I've got pi over 2, 1, pi 0, and 3 pi over 2, negative 1, and 2 pi 0. And you can see that it makes a curve, a wave actually. And if you want to go to the negatives, it's really the same thing, right? Because negative is taking this and just going the other way. So taking my angle and rotating it clockwise. And so if I go negative, negative pi over 2 would be going counterclockwise, going clockwise 90 degrees would land me right here again, and I would be at negative 1. Okay, and if I go negative pi radians, my y-coordinate would be at 0. And then if I go negative 3 pi over 2, so rotate my angle clockwise to 70 degrees, my y-coordinate would be back at 1. And then rotate clockwise 2 pi radians. So go 1 full circle clockwise and back at 0. And this continues. So you can see that the sine function is a wave that continues and kind of repeats every 2 pi. And the y-intercept of this function is at 0, 0. Okay, let's look at the next one. And we're going to do the same thing, except, we don't really need these because we just have to connect these 5 points. And you can see that all of these are right here leading up to the 1. Okay, so here we go. The cosine function. F of x equals the cosine of x. So we're going to do the exact same thing. And we're just going to use our quadrantal angles in this case to help us graph. So 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi would give us 1 full circle. Okay, so cosine of x, now this function is f of x equals the cosine of x, and cosine is x over r, right? Again, because we have a unit circle, r is 1, so cosine is just the x-coordinate of all of these points on the unit circle. So the cosine of 0 radians would be x over r, so in this case x is 1, that would give us 1, and then the cosine of pi over 2, the x-coordinate here is 0, and then the cosine of pi, that would be negative 1, and the cosine of 3 pi over 2 would be 0, and then finally the cosine of 2 pi would be back to 1. And so let's go ahead and graph this. Very similar to the sine function, but instead of starting at 0, 0, we're going to start at 0, 1. Okay, pi 0, pi over 2, 0, and pi negative 1, 3 pi over 2, 0, and 2 pi positive 1. And so if I connect, these will be all my angles in between, right? The x coordinate of all of these points in between would be the curve that I just drew. And then I can also do negatives, right? If I rotate my angle negative pi over 2, so I'm going to go clockwise pi over 2, my x-coordinate is going to be at 0, And if I take the cosine of negative pi, x-coordinate is at -1, cosine of negative 3 pi over 2, x-coordinate is back at 0, and cosine of negative 2 pi, so one full circle, in the clockwise direction, cosine is going to be at 1. Okay, and so again, it's a wave that continues, very similar, except in this case, the y-intercept is not at 0, 0, it is at 0, 1. So I want you guys to do the practice exercise on the next page of your notes by comparing these two graphs. See if you can figure out what the similarities and differences are that you observe, figure out the range and domain, and then using what you know about transformations and parent functions that we learned in Unit 1, I want to see if you can identify the transformations that are applied to each parent function. And you can use Desmos or your graphing calculator to check if you want.